Okay, so of course I have to move everything to one side and then do something with this, factor it somehow to solve. So negative 16t squared plus 80t and minus 64. Because I have to bring 114, I have to change its sign. Negative 114 minus 50 is 64. Of course, that's what we did in class. Again, if you look at the notes, if you redo the problems, you will never have difficulties in my class. Ever, ever, ever. Of course, I'm going to try and divide by negative 16. And see if it works. I hope it does. So this divided by negative 16 is t squared. 80 divided by negative 16 is negative 5. And negative 64 divided by negative 16 is positive 4. And I'm done. And I found two solutions, t equals 1 and t equals 4. So we had the same problem in class. That's why I selected it. Please trust me. I will never sit here and say, is there a problem I have not done in class that I can put on the test? No. I promise. That will never happen. So when we go back to 29, use a comma to separate answers as needed. So the answers are 1, 4 in seconds. And last one, okay. The length of a parking lot is 4 yards more than the width. We had these types of problems, but we didn't know how to solve them a long time ago. So the width and the length is the width plus 4. If the area is 77, find the dimensions. So the area equals 77. So length times width equals 77. The length is W plus 4. The width is the width equals 77. I cannot solve unless I have 0 on one side. I distribute, of course. Minus 77 equals 0. 77, although it looks as a big number, there is only 7 times 11. There is nothing else. And one has to be negative, one has to be positive, and the sum is 4. So then I have 11, a W plus 11 and W minus 4. So W equals negative 11. Not possible because it's a length. So W equals 4. If W equals 4, the length is 8. So we finished the test in an hour, explaining a couple of problems a couple of times because we needed to discuss them. I'm going to add another half an hour minimum, let's say, because you're learning this. I'm not expecting anyone to finish in half an hour or an hour. Okay? But with all the explanations, 60% of the problems required under a minute. I hope you agree that you could have done much better on this test. After test 4, we will make a decision whether we will have a retake. And I cannot give a retake to one student. If it's a retake, it's for everybody. So we will discuss this after test 4. But please study as I'm kindly asking you to study for test 4. Redo the problems we do in class to learn the skill, and then continue with the assignments after you study the material. Please. Okay, so we'll make a decision after test 4. Please register for test 4 and register for the final exam if you plan on taking those. Any questions for me? I was heartbroken to see the results on test 3, but that's not important. What is important is to move forward, finish the material, and review for test 4 and the final, and we'll make a decision after test 4. Because as I mentioned, I replaced the lowest test grade with the final exam grade, so nobody may, need to retake test 3. We'll see. After test 4, we'll make a decision. Okay, we are moving on with Mod 7. Any questions for me, please? Is there anything else from Mod 7 that, again, you have to make the effort to do the work between now and Tuesday. As I said, we're down to 3 weeks, out of which a lot has to be reviewed. Okay. Any questions for me? Anybody would like to say anything? Okay. So in Mod 7, we are in 7.3 now. We have to talk about functions, relations. They're not the same. Okay. So let's start with a function. What a function represents. A function is a mechanism that connects a value from one set to a value from another set. I'm going to write the definition. So let's say I have 1, -3, and 4. 1 corresponds, let's say, to 7. -3, I'm just putting some numbers in there to explain. 4 and 10. So these are the so-called values of x, also called domain. This set is called the set of values of y, also called range. And as you notice, x and y, I created ordered pairs. 1 corresponds to 7, meaning I created an ordered pair 1, 7. -3 corresponds to 4. And 4 corresponds to 10. So again, what is a function? Function. Correspondence. Correspondence of one value of x to exactly one value of y. So a function makes x correspond to exactly one value of y. X corresponds to 1y. X corresponds to 1y, and so on and so forth. So this is a function. Now we can have this situation, and look what happens here. 3 corresponds to 0 and 4. This is not a function, because I found an x value that corresponds to 2 or more y values. This is called a relation. Does it exist in real life? Yes, but it's not a function. So an easier way to remember the definition of a function is this. Each input, this is the input, corresponds to only one output. That's the shortest and the easiest to remember. Each input corresponds to only one output. If I find more than one output, it's not a function, it's a relation. The sets for a relation are still called domain and range. This is the domain of the relation, this is the range of the relation. So the sets are named the same. But the relation does not have each x corresponding to only one y. Okay. Any questions? Please stop me. Please stop me. Now, let's look at the following. I just put some numbers, 1, 2, 3, 4, 5. Is this a function or a relation? It cannot be both. Is this a function or a relation? It cannot be both.
Relation?
Let's refresh our memory. Each input corresponds to only one output. Yes, it is a function. So two x values can go to the same output. Each x to one y, each x to only one y, each x to only one y. So this is a function. Now, if I want to present the domain, here's how I present the domain for this function. 1, 2, 3. That's it. That's all it has. How do I present the range? Just 4, 5. There is nothing else. Any questions? Any questions? Okay, moving on then. What if I have graphs? So let's look at a few graphs. I want to identify which ones represent functions and which ones do not represent functions. So this is the coordinate system. And let's look at a few graphs. Here's one. Here's the other. And here's the last one. How will I know which ones represent a function and which ones do not represent a function? Here's the idea. By the vertical line test. By the vertical line test. What does that mean? So I will draw vertical lines through the graphs. Okay, the first one. This another line, and then the second one, another line, and then the third one. Some vertical lines. Now, to this x value, how many y values do you think will correspond? The answer is 2. Because it crosses the graph in 2 points, and I will read the y value. It crosses the graph in 2 points, and I will read the y value. Relation. By the vertical line test, the first graph represents a relation. Because I found a vertical line that crosses the graph in more than 1 point. Which means this situation. I found an x value for which I read 2 y values or maybe more. So it's a relation. Can anyone tell us about the second one? Is the second one a function or a relation?
Function.
Say it again.
Function.
Yes. For each x value, I read one corresponding y value. For this x value, I read one corresponding y value. So this is a function. What about the last one? Function or relation?
Function?
Yes. For the same reason, for each x value, I get only one y value. Perfect, thank you. Now, notation. We already use this notation for polynomials. But we normally denote functions by f of x. Please do not read this f parentheses x or f multiplied by x. This is f of x. But it could be g of x, it could be h of x, it could be t of p, and so on and so forth. Anything you can think of. Now, how do we evaluate? Exactly as we've done even today when we reviewed the test. So let's say I have a function f of x equals negative 2x squared plus 3x minus 2. And I want to evaluate it for 0, and I want to evaluate it for negative 1. What does this mean? It means that everywhere you see x, you have to replace it by 0. Then, everywhere you see x, you have to replace it by negative 1. So, I'll come back here for a second. Just give me 1 second. I want to explain something. Remember, the pattern is the most important. To understand the pattern. What do I see here in this function? I'm going to copy it here. 2x squared plus 3x minus 2. This is what I see. I see the pattern. And now you can ask me to evaluate it for anything. Yes, I can plug it in the graphing calculator as I showed you today again and get in the numbers. That's fine. But I should be able to simplify it and evaluate it by myself with no calculator. Because I see the pattern. What is the pattern? F of whatever is negative 2 times whatever squared plus 3 times whatever minus 2. Now, this whatever, which is x, first is 0 and then is negative 1. For 0 is always very easy for polynomials. 0, 0, negative 2. For negative 1 is also easy. Negative 2, negative 1 squared plus 3 times negative 1 minus 2. But if you don't remember that negative 1 squared is positive 1, and you come up with negative 1, the whole thing collapses. We discussed that a negative number raised to an even power is always positive. Now it will end up being negative because there is a negative 2 in front. So this is 1 times negative 2 is negative 2. Negative 2 minus 3 is negative 5. Minus 2 is negative 7. And you can always, if you have any doubts, if it's a test situation, you can always go back. Go back to the graphing calculator, put it in y equals, clear whatever, put in negative 2x squared, and then plus 3x minus 2. Very easy. And plug in 0. So right here, negative 2. And plug in negative 1. And we will get negative 7. And it's done. Any questions? Okay. Now, if this is the graph of a function, any point on the graph has to verify the equation. Must verify the function or the expression f of x. If a point is out here, not on the graph, this point will not verify f of x. Meaning, here's an example. Let's say f of x equals 2x squared plus 3x minus 2, a different problem. And we're asked, is 2 comma 12 a point on the graph of f of x? Is it? I don't know. How do I verify? Anyone has an idea how to verify? I want to verify this is the graph, let's say, of this function. It's not, but this is the graph of f of x, and they're asking us, is 2 comma 12 a point on the graph or somewhere outside? How do I verify? We have basically two notations for f of x, the same thing with y. So I replace x by 2 everywhere and y by 12. So if 12 f of x equals 2 multiplied by 2 squared plus 3 times 2 minus 2, if the left-hand side equals the right-hand side, then I'll say yes, this point is on the graph. If the left-hand side does not equal the right-hand side, then I'll say, sorry, it's not on the graph. Can anyone tell us whether it is or it is not on the graph? Can anyone tell us whether it is or it is not on the graph?
It is?
Yes, because 4 times 2 is 8. 8 plus 6 is 14. 14 minus 2 is 12. Yes, 2 comma 12 is on the graph of f of x. Why? It verifies the equation. Since it verifies f of x equals 2x squared plus 3x minus 2. When x is 2, y was 12. F of x or y mean the same thing. Very good. The same question for f of x equals the absolute value of x minus 2. And the question is -4, -6 on the graph of this function or not?